Today's lesson is about adding, subtracting, and multiplying matrices. Now, matrices, so far we've been doing row operations on matrices, but the fact is that matrices are a lot like numbers, and they can be added, subtracted, and multiplied. And also, like numbers, they can be, we can tell if two matrices are equal to each other or not. So the first thing I just want to mention is matrix equality. Two matrices are equal if they have the same dimensions. So they have to have exactly the same number of rows and columns. And if each corresponding element, which is what we call the numbers in a matrix, are equal. So if you have a matrix like 1, 2, 3, 4, the only matrix that it's equal to is 1, 2, 3, 4. There's no other matrix that's equal to the matrix with the 2 by 2 matrix with those 4 elements. So there are some questions they could ask you. For instance, they could say if x2, 3y, if they tell you that these two matrices are equal to 1zw4, they could ask you to find the values of x, y, z, and w, and in this case, of course, x would have to equal 1, and y would have to equal 4 for these matrices to be equal, and z would have to equal 2, and w would have to equal 3. So that's just a real sort of easy thing that you can do with matrices. When we know two matrices are equal, all their corresponding elements have to be equal to. Next thing I want to show you is that just like you can add two numbers together, you can add two matrices together, only if they have the same dimensions. So for instance, the matrix, the 2 by 2 matrix 1, 2, 3, 4 can only be added to another 2 by 2 matrix, for instance 5, 6, 7, 8. And it's just like you would expect it to be. You add the corresponding elements together. 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. So adding matrices, if they have the same dimensions, it's very easy. You add the corresponding elements, and that becomes the new answer. If they have different dimensions, there's no answer, so then they can't be added. We could do a little question that combines the two ideas of equality of matrices and of adding matrices. I could ask something like this: if x2, 3y plus 5zw8 is equal to 6, 8, 10, 12. I could ask you to solve for w, x, y, and z. Very simply, the top left element, x, 5, and 6, so that would be x plus 5 equals 6, or x equals 1. The top right would tell us that 2 plus z has to equal 8, which would make z equal 6. The bottom left would be 3 plus w equals 10, so w equals 7. And finally, the bottom right is y plus 8 equals 12, so y equals 4. Now, subtracting matrices. Is similar to adding. If I had 1, 2, 3, 4 minus, and this time I'll make the 5, 6, 7, 8 go this way. So you can only subtract matrices if they have the same dimensions, which these do. And then you do top left minus top left. 1 minus 5 is negative 4. 2 minus 7 is negative 5. 3 minus 6 is negative 3. And 4 minus 8 is negative 4. So subtracting matrices is similar or almost the same as adding matrices. They have to have the same dimensions or there's just no answer. Now multiplication gets a little bit more complicated. There's two types of multiplication, and the first one is called scalar multiplication. Oops. Scalar multiplication is when you multiply a regular number times an entire matrix. Sometimes a constant is called a scalar. Well, you can actually multiply a regular number by an entire matrix, and you do it by doing looks like the distributive property. Multiply the 5 by each of the elements. So the top left times 5 is 5. If it goes on the top left, the top right times 5 is 10. The bottom left times 5 is 15. The bottom right times 5 is 20. And that's what's known as scalar multiplication. We're multiplying a matrix by a number. But where this gets complicated is when I show you how it is that we multiply a matrix by another matrix. I'll just call this matrix multiplication. So suppose I wanted to multiply together the matrix 1, 2, 3, 4 multiplied by the matrix 5, 6, 7, 8. It seems reasonable that just like adding matrices, that it just be 1 times 5 is 5, 2 times 6 is 12, 3 times 7 is 21, 4 times 8 is 32. Now it turns out that it would be great if this was true, and it would make this lesson really easy to do. But watch what happens when I go to the graphing calculator. If I make a 3 by 3 matrix, whoops. If I make my first 3 by 3 matrix, the number is 1. No, I don't want to make it 3 by 3 matrix. I want it to be a 2 by 2 matrix. If I do make my matrix A with numbers 1, 2, 3, and 4, and then I go to the matrix menu again and make matrix B. Oops. It's just trying to put matrix B into this fourth element, so I better not do that. And just put 4 here and hit enter. I think I better just quit out of that and then go back to the matrix. Now I can edit matrix B. Matrix. Sorry, I forgot to go over to edit. Go to the left. Matrix B. So I'll make this one 5, 5, 6, 7, 8. I'll quit these. Second quit. And then when I multiply them, second matrix A. There might be an easier way to get those up, but none that I know of. Times second matrix B. We find that 1, 2, 3, 4 times 5, 6, 7, 8 is not 5, 12, 21, 32, but it is 19, 22, 43, 50. So that's sort of a mystery. A second mystery is why is it that if I multiply them in the opposite order, second matrix, if I did B multiplied by A, I would get 23, 34, 31, 46. So two mysteries. One is why isn't it just the obvious 5, 12, 21, 32? Secondly, why is it that matrix multiplication seems to not be commutative? Why is it when I change the order I get different answers? So 1, 2, 3, 4 times 5, 6, 7, 8 ends up equaling 19, 22, 43, 50, while 5, 6, 7, 8 times 1, 2, 3, 4 equals something different. It becomes 23, 34, 31, 46. So I'm going to resolve both of those mysteries. And another thing is that you can't always multiply two matrices that are the same size like you could with adding. 1, 2, 3, 4, 5, 6 times 7, 8, 9, 10, 11, 12 turns out to be undefined. It's not even possible to multiply them. Whereas if I multiplied 1, 2, 3, 4, 5, 6 times, this is a 2 by 3 matrix, by 7, 8, 9, 10, 11, 12 this way. So here I've got matrix B is that 7, 8, 9, 10, 11, 12, that 3 by 2 matrix, whereas matrix A is 1, 2, 3, 4, 5, 6. So let's see what happens when I multiply those together. Second matrix A, you can do this pretty quick with just a regular calculator, you pushing the buttons. A times B, second matrix, and that one turns out to be defined and has an answer of 58, 64, 139, 154, and we'll try to learn how that happens. And I'll show you in the next few minutes why that is. And I'll show you with this example. The first rule about matrix multiplication is determining whether you can multiply them or not. We write the dimensions of the matrix on the left, which is 2 by 3, 2 rows, 3 columns. And the dimensions of the second matrix, the one on the right, it's got 3 rows and 2 columns. Only if these two numbers match is it possible to multiply the two matrices together. That's why this example over here doesn't work, because it's 2 by 3 trying to multiply it by another 2 by 3. This 3 and 2, whoops. As I was saying, this 3 and 2 do not match. Okay, so what happens after it passes the first test, where the number of columns in the one on the left equals the number of rows on the one on the right, and then we can proceed? Well, the answer, there will be an answer in this case, and the dimensions of the answer is going to be the other two numbers. It's going to have this many rows and this many columns, so it's going to become a 2 by 2. And what I like to do is put slots, little horizontal lines, to indicate the spots there. Well, since I'm hitting the 15-minute limit, I'm going to leave this for the next part of this tutorial, to be continued.